In this video, I'm going to quickly explain how to algebraically find the steady state of a system. So this is problem number 1 on part 2 of the homework, and I'm going to explain part B, where it says find algebraically the steady state of the system S. So what we want to do to find the steady state is we take our, I called it P, but it's T, the transition matrix, times S, and then set that equal to S again. So, because what happens is when we have a steady state matrix, when we keep multiplying over and over and over, we get the same state back again. So that's why we set up that equation. Our T, the transition matrix that we're given, I used P because I was thinking probability matrix, but it's a transition matrix, so it's T. So it's 0.3, 0.05, 0.7, 0.95, and that's given in the problem. Then we're going to multiply that by S1 and S2 and set it equal to S1 and S2. When we multiply, it's 0.3 times S1 plus 0.05 times S2, and then that's going to equal S1 because that's on the top row. Now, we could do the same thing with the bottom row of the transition matrix, but it's just going to give us a system that will give us infinitely many solutions. So instead of using that bottom row, because they're probabilities, we know that our two steady states have to add up to 1. So that's where I got S1 plus S2 equals 1. I decided to solve using substitution. Since I had one S2 and two S1s, I decided it would be easier to isolate S2 and then substitute for that variable. So S2 equals 1 minus S1, which means that 3/10 S1 plus 5/100 times 1 minus S1 equals S1. I distributed, and that's how I got that next line. 3/10 S1 plus 5/100 minus 5/100 S1 equals S1. Combining like terms on the left, 25/100 S1 plus 5/100 equals S1. I subtracted S1, 25/100 S1 from both sides, then divided by 75/100. I got a crazy decimal in my calculator, so I pressed math, enter, enter, and it gave me 1/15. I know that S1 plus S2 has to equal 1, which means S2 is 4/15, which means my steady state matrix is 1/15, 14/15.